Okay, the circuit itself is quite simple. It's just a battery with an internal resistance connected to one external load. We are told that in the second circuit we have the same EMF, but the internal resistance is much larger, and yet it's the same currents that's pushed through the external resistor. So this can only mean one thing: the external load in the second circuit has got to be smaller compared to the one in the first circuit. Alright, so let's talk about terminal PD first. So the terminal PD is the PD between these 2 points, and it's easy to just think of it as the EMF minus away the potential difference that's in the internal resistance, and that will be I times R. So the terminal PD in P has got to be higher compared to Q, because P has a much smaller resistance, so internal resistance. So the PD drop in the internal resistance is much smaller compared to this one, because the current is the same. That's a crucial point, the current is the same. And what about the power that's dissipated in the external load? That will be the output power, right? The power that's dissipated in the external load will be the output power. So the output power we can simply think in terms of I square R. And again, because the current is the same in both cases, in P we have a larger external load. That's why the output power in P is larger than in Q. Easy.